Good morning class and welcome to our classroom. This is Teacher Jofi and our topic for today is operations and functions. Let's look at our objectives. At the end of the discussion, you should be able to number 1, define operations and functions, number 2, identify the different operations and functions, and number 3, perform addition, subtraction, multiplication, division, and composition of functions. Let us start with this short drill. I encourage you to answer the questions to stimulate your brain for our discussion for today. So here's the first question. What is f of 3 when f of x is equal to 5x plus 4? Remember, this is just evaluation of function that we had discussed yesterday. So again, what is f of 3 when f of x is equal to 5x plus 4? Okay, this is very easy. The answer is 19. I think you got it correctly because you are very cooperative in our lesson yesterday. So let us proceed to the next question. What is 7x minus 5 minus x squared plus 2x minus 1? Again, what is 7x minus 5 minus x squared plus 2x minus 1? Okay, this is subtraction of polynomials. Okay, you try answering. Okay, our answer is negative x squared plus 5x minus 4. Now let us recall how we answered this. Okay, let's look at the solution. Okay, we have 7x minus 5 minus the quantity x squared plus 2x minus 1. Because we have subtraction here, okay, we will distribute this to all the terms inside this parenthesis. Okay, so we will have 7x minus 5 minus x squared, and then negative times positive 2x there, you have negative 2x, and negative times negative 1 there, we have positive 1. And then combining like terms, we have negative x squared there, has no other similar term. Okay, so we put it there. Okay, and then the ones with x, the terms with x, so we have 7x and we have negative 2x. 7x and negative 2x or minus 2x, that gives you 5x. And then we combine the constants, negative 5 and positive 1. Negative 5 plus positive 1 is negative 4. Therefore, our answer is negative x squared plus 5x minus 4. Here's another question. What is f of x minus 1 when f of x is equal to 2x plus 3? Okay, we also have discussed this yesterday. What is f of x minus 1 when f of x is equal to 2x plus 3? You may try solving it. Okay, so you can compare your answer with our answer here. Okay, if you need more time, you can pause the video and try to answer it on your own. Now I will give the answer. The answer is 2x plus 1. Now here is our solution. Okay, so we have f of x is 2x plus 3 taken from this. Okay, and then since we're looking for f of x minus 1, we will substitute x minus 1 to 2x here. Okay, so we have there f of x minus 1, we substitute x minus 1, 2x there. Okay, and then 2x plus 3, we substitute x minus 1, 2x here. Therefore, we have 2 times x minus 1 plus 3. Okay, and then distributing this, we have 2 times x, we have 2x. 2 times negative 1, we have negative 2. And then we have to bring down positive 3 there. Okay, so we have 2x minus 2 plus 3. Finally, combining like terms, we have 2x there has no similar term, so you have 2x. And then we combine the constants, negative 2 plus 3, you have positive 1. Therefore, our final answer is f of x minus 1 equals 2x plus 1. Okay, those are the drill questions. Do you remember the 4 mathematical operations? Yes, very good. So you remember it's addition, subtraction, multiplication, and division. So this is where we base our definition for our operations and functions. So basically, we also have addition, subtraction, multiplication, and division of functions. Let us have this definition, okay? We will define the operations and functions. So we assume that f and g are functions. So usually, as we have learned yesterday, f of x is a function, or f here represents a function of maybe another variable like f of x, and then g can be a function also of x. Okay, so we have f and g as functions. Now we define the sum or addition of functions. Okay, so we have f plus g of x equals the sum of f of x and g of x. Okay, we will have an example for this later on. For subtraction or difference, we define it as f minus g of x equals f of x minus g of x. And for the product is for multiplication. Okay, we have this symbol, the dot symbol, which means multiplication. F times g of x equals f times g of x, or f of x times g of x. And then for the quotient, we have f over g of x, or we have f divided by g of x equals f of x divided by g of x. Now we have to make this exclusion that the value of x where g of x equals 0 should be excluded in the domain of this function. Okay, and then we have composition of functions. The composition of functions is new because we don't have composition in the basic mathematical operations. So composition is for functions. It is defined as, there you have a small circle here. Okay, we call it f composition of g of x equals this one, f of g of x. Now I just want to clarify and distinguish between the product or multiplication here. We have here a dot which is closed. This means multiplication. If you have a circle, this one is open. It's not shaded. Okay, this one is composition. Okay, so we read this as f composition of g of x is equal to f of g of x. Let's look at the examples. Okay, so let's have the first example. This is for addition. We are given the function f of x is equal to x minus 3, g of x equals 4x plus 2, and h of x equals 3x squared minus 5x plus 8. Okay, we are asked to find f plus h of x. So by definition, this one is f of x plus h of x from this f plus h. Okay, so we will substitute f of x and then h of x here. So as you notice, I have color coded this, so it will be easy to compare them or to find them. F of x here is taken from this x minus 3 here, and h of x, the green one, from here. Okay, so we have f of x is x minus 3, and then h of x is 3x squared minus 5x plus 8. Okay, so we have followed the definition here. We have substituted. Okay, now we have to combine like terms, or we call it simplification. We simplify by combining like terms. Okay, so when we combine like terms, we start with the ones with the highest exponent, okay, or the degree. We have here 3x squared. And there is no other term with squared. So we can take this there, okay, and then we combine the ones with x's, x here, and 5x. So x plus negative 5x, you have there negative 4x. And we combine the constant, negative 3 plus 8, you have positive 5. Therefore, f plus h of x equals 3x squared minus 4x plus 5. Let's look at subtraction. This is example number 2. We're asked to find f minus g of x. We're given the same functions. Okay? So, by definition, f minus g of x equals, we have this subtraction, f of x minus g of x. And we substitute. F of x is x minus 3 here. And g of x is 4x minus 2 here. Okay? Now, I want you to take note of subtraction. For subtraction, this is not the same as addition because for subtraction, the rule is change the sign of the subtrahend. Okay? So, we change the sign of this subtrahend. The second term is the subtrahend this. Okay? So, we will change this sign. So, positive 4x becomes negative 4x, and positive 2 here becomes negative 2. Okay, therefore we have x minus 3, we brought it down, and then this one we change the sign, becomes 4x, negative 4x, and positive 2 here becomes negative 2. Okay, and then we can combine like terms. The ones with x, and negative 4x here is negative 3x. And negative 3 and negative 2 is negative 5. Therefore, our final answer is f minus g of x equals negative 3x minus 5. So that is for subtraction. Okay, now let's look at multiplication. We have f times g of x. And by definition, this one is f of x times g of x. Okay, and we substitute the values of the function, or we substitute the function. F of x here is x minus 3 taken from this, and g of x is 4x plus 2 taken from g of x. Okay, and since we are multiplying, we have two terms here, x minus 3, two terms, and 4x plus 2, two terms. We are multiplying two terms. And by rule, when we do that, we use the FOIL method. FOIL is F-O-I-L, for F for first, O for outer, I for inner, and L for last. Okay, so first, this is the first term, and the first term here we multiply, and then outer, the outer ones, this and this. Okay, and then the inner, negative 3 and this, and then last, negative 3 and positive 2. Okay, so we'll start with the first. X times 4x squared. Sorry, it's x times 4x. We have 4x squared. Okay, and then we have the outer x times 2. You have positive 2x. Negative 3 times 4x. You have negative 12x. And negative 3, this is not the last and the last here. Negative 3 times 2, that's negative 6. Okay, so that's how we apply the FOIL. And now we combine like terms so we can simplify. So since 4x squared has no similar term, we put it down, we copy 4x squared. And then we combine the ones with x, 2x and negative 12x, positive 2 and negative 12x, that is negative 10. Okay, so we have the 4x squared, negative 10x, and bring down negative 6. Okay, so for our final answer, f times g of x equals f 4x squared minus 10x minus 6. So let's have example number 4. g over h of x. This is actually division, and this is defined by g of x over h of x. So we substitute now the function g of x in the numerator. We have 4x plus 2 taken from this given. And then for h of x, the green function, this is 3x squared minus 5x plus 8 taken from this given function. Okay, since we can no longer simplify this function here, there is no common factor between the numerator and the denominator. This is now our final answer. So therefore, we have g over h of x is equal to 4x plus 2 all over 3x squared minus 5x plus 8. Let us have example number 5. This is composition of functions. F composition of g of x. And this is defined as f of g of x. This means that we will substitute g of x, or the function g of x, in the x's or the x variables of the function f. Okay, let's look at it this way. Our f here is x minus 3. F of x is x minus 3. Okay, now f of g of x means we have to substitute 4x plus 2, which is g of x, to the x here in f of x. Okay, so it will turn out that this one becomes your x here. So we will have, okay, we now have, this is now the x part in f of x, and then you have here negative 3. This means that we substituted g of x in the x variable in this f of x. Okay, and now we simplify. 4x here has no similar term, therefore we can bring it down. Okay, and then we have the constants, positive 2 and negative 3. 2 and negative 3, or 2 minus 3 is negative 1. Therefore, you have 4x there brought down, and then plus positive 2 minus 3 is negative 1. Therefore, our answer, f composition of g of x, equals 4x minus 1. Okay, so that is for the composition of functions. So before we continue with our examples, I want to give this to my students. So shout out to my students at Southville 8B Senior High School. I want to give you this for your attendance and class participation. Please answer this question. Is f composition g of x equal to the g composition of f of x? Why or why not? Prove your answer by showing an example or counter-example. So don't worry, class, my students, if your answer here is not very sure, or it seems that it's not correct. It's okay. What is important is that you have your attendance and class participation. So I want you to send your answers to me through private message. Okay, so that is for my students at Southville 8B Senior High School. Let us continue with our examples. We are now at number 6. We have f plus h of 2. By definition, we have f of 2 plus h of 2. Okay, so we do it by, okay, we have by looking at the functions first. So we have f of x is x minus 3, and then h of x here is 3x squared minus 5x plus 8. Okay, and then we substitute 2 to all the x's in the function. So we have f plus h of 2 equals 2 minus 3 plus the quantity 3 times 2 squared minus 5 times 2 plus 8. So notice that the x's have been replaced with the number 2. Okay, negative 5x here is this with 2. And then we will try to work on the operations. We have 2 minus 3 here. We have negative 1. And then the next term we'll start with this exponent. 2 squared here is 4. So you have there 3, and then 2 squared is 4. And the negative 5 times 2, you have negative 10. And we bring down 8. Okay. And then we'll simplify. Negative 1 here is brought down negative 1. 3 times 4 is 12. And negative 10 plus 8 is 2. Or sorry, negative 2. Negative 10 plus 8 is negative 2. Now combining all this, we have negative 1 plus 12, that's 11, minus 2, that is 9. Therefore, f plus h of 2 equals 9. Let us look at the next example. We have f minus g of negative 1. By definition, we have f minus g of negative 1 equals f of negative 1 minus g of negative 1. Okay, and we can directly substitute negative 1 to x minus 3 here. So we have there, f is x minus 3, so we now replace x here with negative 1, so we have negative 1, and then we bring down negative 3. And then the operation, subtraction, then we have g of negative 1, this is g, 4x minus 2. We replace x here with negative 1, so we have 4 times negative 1, and then we bring down 2. Okay, working on the operations, we have negative 1 minus 3 here is negative 4. Okay, and then we copy the subtraction sign. 4 times negative 1, it's negative 4, and then we bring down 2. And then we simplify again. We have bring down negative 4, and then negative 4 plus 2, it's negative 2. Okay, and then negative 4, we bring down again. Negative of negative 2 becomes positive 2. And applying the operation, we have negative 4 plus 2, we have negative 2. For our final answer, we have f minus g of negative 1 equals negative 2. The eighth example, we have f times g of negative 2. So again, we extend the definition. We have f times g of negative 2. We replace it with, or we define it by, f of negative 2 times g of negative 2. Okay, and directly replacing x with negative 2. So we have, for f here, we have x minus 3, we replace x with negative 2, so we have negative 2 minus 3, times, for g of negative 2, we take the function g here. For x plus 2, we replace x with negative 2, so we have 4 times negative 2, and then we bring down 2. Applying the operations, we have negative 2 minus 3, we have negative 5. And then for the second one, 4 times negative 2, we have negative 8. And then we bring down 2. Simplifying this part, negative 8 plus 2 gives you negative 6. And we bring the negative 5 here. Now this, we have a product here because this is now multiplication. Negative 5 times negative 6, that gives you 30. Finally, f times g of negative 2 is equal to 30. We're almost there. For division, g over h of 0. So by definition, you have g at 0 divided by or over h of 0. Substituting 0 to the functions, okay? So our g is 4x plus 2. We replace x with 0, so we have 4 times 0 plus 2. And then, for h, the h function, we have this, 3x squared minus 5x plus 8. We replace the x's with 0, so you have 3 times 0 squared, and then negative 5 times 0, and then we bring down 8. So this one becomes 0. You're left with 2 here. And then 0 squared is 0 times 3, that's 0. And then 5 times 0 is 0. You're left with 8. So that's 2 over 8. Finally, we simplify this. 2 over 8 is 1/4. Therefore, g over h of x is 1/4. This is now our final example. So we have f, composition of g at 1. And by definition, this is f of g of 1. We start with g at 1. Okay, going back to g of x here, we replace x with 1. So 4x plus 2 should become 4 times 1 plus 2. Okay, 4 times 1 plus 2. And we replace this to the x in f. Okay, so this one should be replaced with 4 times 1 plus 2. So you have it here, 4 times 1 plus 2. This is now this x here. And then we bring down negative 3. Okay, and then applying the operations, we have 4 times 1, that's 4. We bring down 2, and we also bring down negative 3. And simplifying this, we have 4 plus 2, that is 6, minus 3, and that is 3. Therefore, f plus g at 1 is 3. We have an alternate solution here. Or this one is just an expanded form of what we have just done here. So let's look at step 1. Okay, so we start with the given. So f composition g of 1 equals f of g of 1. Okay, so we start with finding g of 1. So we have there g at 1 equals 4 times 1 plus 2. Here, taken from this. So it's 4 times x becomes 4 times 1. And then we bring down 2 here. Okay. And then we simplify. 4 times 1 is 4 plus 2, that is 6. So we have g at 1 equals 6. When we're able to solve this, we can now go to step 2, finding f at g of 1 by substituting the value of g of 1, which is now 6. Okay, so we have f of 6, okay, taken from g at 1. G at 1 equals 6 here. So we now have f of x here. Okay, so going back to the function, f of x here, x minus 3. Okay, so we replace the x with 6, f at 6. Okay, and then 6 minus 3. So 6 minus 3 equals 3. Therefore, we now have f circle g, or f composition g of 1 equals 3. So there you go. That is all for today. Now it's your turn to work. Please get your module and answer the exercises indicated in your weekly home learning plan. So God bless you and have a great day, everyone.